All right.
All right.
Good.
Oh my goodness. You two are going to be the death of me. All right. So we are now about to embark on the happy world of sequence and series. So in other words, I should be able to give you a list of numbers. You should be able to look at it and tell me the pattern that is happening.
Oh man.
You will be able to write me an equation to find any number in that pattern. And we will also, when we get to 10.2, look at the equation that if I took all those numbers in that pattern and added them together, what the grand total would be. So that's the goal that we're going to accomplish through 9-1, 10-1, and 10-2. So we're looking at sequence. A sequence is just an ordered list of numbers. And your terms are all of the numbers in the sequence. So, in other words, 13 is a term, 15 is a term, 17, 19, 21. Okay, those are all individual terms. So, if you look at number 1, what is the pattern?
Plus 2.
Plus 2. We're adding 2. Okay? Take a look at number 2. What is the pattern? Okay, you went over to 3.
Yeah.
Oh, you're okay. You're okay. I was like, wait a second, what? Okay. So technically number 3 is minus 8. What's my pattern for number 2?
Times 2.
Times 3. And what is the pattern for number 4?
Plus 2? Oh, no. They don't have to.
It isn't a pattern.
But there is one.
No, there's not.
Minus
Wait, no.
Oh, it's
minus 2.
Plus 2 minus.
No, they
no, it's minus
Right, it's
2
minus 2.
plus 7.
Oh, yeah, it is.
Right?
It's minus 2 plus 7. Minus 2 plus 7.
Okay, so you're going, it's minus 2 plus 7, but then this one should be minus 2, right? That don't work.
No fuck.
Language.
I'm free.
English.
There is a pattern here.
No. I don't know. Just tell us. No.
I have no idea. Divided by
Just
something.
tell us.
Just tell
Is
us.
it divided by something?
No,
Is it multiplied by something?
no.
Is it added by something?
It's the previous number. I don't know.
I don't know what it is.
All right. -3 minus -5. So you're taking this number and subtracting this number
Say
each
what?
and every time. -3 minus, which becomes plus a positive, that gives me 2. -5
You ain't even touched it.
minus 2 is -7. 2 minus -7 is +9.
Please don't ever give us that kind of
First
question
of
on the test.
Mwah!
Because I would never understand that.
Yeah, they ain't teaching us.
He's staring at the paper for like 10 minutes, bro.
I'm wondering why you gave me this. Seriously. I'm gonna write a little note like, why in the hell did you think
I'm gonna just write a big question.
You know, kind of like that one problem where they had a triangle on there and they had X next to the hypotenuse and it said find X and the poor kid just circled it and said, there it is.
Oh.
I mean, it said find X.
So technically, he's not.
Technically, he wasn't wrong.
So if I do that, it'd be alright.
You give us points for creativity.
Creativity.
Now, do you explain to me what's mine?
I'm
Right,
right for
explain
thinking
why.
outside the box.
Right.
All right.
Miss Smith.
Yes.
What was the last one?
-2 minus -7 equals 9.
Like I heard it.
2 minus -7 equals 9.
What I just
Yeah, you said it real fast.
And you way up here and she's way back there and you're speaking this way. You're like my husband. Like I'll be walking behind him and he'll be walking ahead and he's like, blah, 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 blah. I'm like, you are talking to the blank space in front of you. I'm back here. I can't hear you. Hello.
They get mad because we didn't hear.
Right.
Probably at work.
All right. So now we're going to go back and we're going to write what we call recursive sequence. Okay. The terms in the sequence are based on using previous terms. So, in other words, in order to write a recursive sequence or a recursive rule, I have to know what's happening beforehand before I can find out what's going to happen next. Okay. So, your recursive rule is an equation statement for the pattern of the sequence. Your seed is the starting term that are needed to begin the pattern. Okay, so what everybody gets messed up with is everything we're about to get talking about next.
Oh,
Okay, so I'm going to try to break this down as best as I can. Okay. So let's make up a sequence. What rule do you want to use? Pick me a rule. Pick me a pattern. What do you want to use?
+7.
+7. All right. So if I start with 1 and I add 7, that takes me to 8. Add 7, that takes me to 15. Blank, blank, blank. Okay. So they would call this sequence A. Okay. They would call this sequence A. So A is just a variable that names the sequence. Okay, so they can call your sequence S, they can call it T, they can call it anything they want, but they're going to use a variable. Okay. Each part of the sequence then, this is A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, A sub 6. Okay, so A represents that I'm in the A sequence, and the subscript that they use tells you where your number falls. This is my first number in the sequence. This is my second number in the sequence. Okay, so N represents the term location. Where is it? And A sub N represents the term value. So, in other words, A sub 1 equals 1. That means the first number in the sequence A has a value of 1. Have I completely lost anybody yet? Have I somewhat lost people? Kind of, sort of, a little bit. Okay. All right. So now, you need to be able to write a sequence. I need to be able to come up with some equation that shows me that I can take this and continue on and find my next number. Okay? So normally, we would have taken 1 plus 7 and gotten 8. You would have then taken 8 plus 7 and got 15. Okay? Then we take 15 plus 7, and that gives us what? 22. So this number here is 22. I now need to write this as an actual equation.
Oh, wow.
So What is something that does not change in this entire equation?
Plus seven.
Plus 7 does not change. Plus 7 does not change. Okay, that does not change. Okay. To get this answer, okay. To get this answer, I need to go back to this one. To get this answer, I need to go back to this one. To get this answer, I need to go back to this one. Okay, so if I want to get this answer, I've got to go back to this. Well, in order to go backwards one space, we call that a sub n minus 1. This shows that I'm going backwards one space. And what am I doing to that number? Well, I'm adding 7. That's your recursive rule. You have to tell them how many spaces to go back so you can use that number, and then you have to tell them what to do with it. If I wanted to go back 2 spaces, I would use a sub n minus 2. If I wanted to go back 3 spaces, we'd use a sub n minus 3, so on and so forth. What if I wanted to go forward a space? N plus 1. Okay. So it's just the distance from what you're trying to find. So let's go back to this. So in order to get this next number, what would I do? Mathematically, you would take what and add 2? 21 plus 2. Okay, so you went back 1 space and then added 2. So this would be a sub n minus 1 plus 2. That's your recursive rule. Okay. Let's jump over to number 3. I want to find this number. How would I do that mathematically with numbers? Okay, negative 21 minus 8. So, in other words, I need to go back 1 number, so a sub n minus 1, and I need to subtract 8. There's your equation. That's it.
Oh, okay.
Everybody gets mixed up with the a sub n minus 1, though. Okay? How would I get this number? Using numbers. 324 times 3. So I need to go 1 number back, a sub n minus 1, times 3. Or you can also write that as 3 a sub n minus 1. Both of those mean the same thing. Okay, so it doesn't matter whether you multiply at the end or multiply at the beginning. Okay, so take a look at this one. If I want to get this next number, what would that look like?
9.
Hold on, go back and look at it. So we took this one minus this one to go here.
So it'd be -7.
Negative 7 minus 9. It's going to give you negative 16. Okay, so I had to use this number. How many spaces back is that number? 2. So this is a sub n minus 2. And then I want to subtract. How many spaces back was 9? 1. A sub n minus 1. You told me I have to go 2 back and then subtract 1 back. So I went 2 back minus 1 back. questions? Answers? All right. Let's see if we can write some from words. Ha 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 ha. Oh, yes. All right. It's not technically word problems. You're just setting up the equation. You're not doing anything with it. You're not doing anything with it. So they want to find the next term in the sequence. So they want to find a sub n. Okay. Let me do this. Okay. So we want to find this number. Okay. A sub n. It says it's equal to 3 times the previous term. So that means I need to go backwards 1 and do what? Times 3. So 3 times the number that comes before it.
Oh no, this ain't gonna make sense.
Exactly.
But you just told me what to do.
Doesn't mean we know what it.
See, you explaining it and then on the test is 2 different things.
It's like, yeah, I know it.
Doing it and understanding.
Actually, no, let's go to number 2. I left. Let's go to number 2. Okay. I'm trying to find this number.
Why are you trying to find that one?
Right, why can't you find
Just
it?
any number. I'm just trying to visualize how many spaces we need to go back.
Then why can't we do the first
Right.
Well, there's no
Because there's nothing before it.
So,
one? So how will we know to get the other number?
if you don't got no numbers, how do you know to choose the third number? Because you don't know how far you gotta go back.
Exactly. That's why I was
It's
confused why
saying
you start third.
that the sequence A is equal to 3 times the previous term. Is asking for a previous term, and you're going to multiply that by 3.
Okay, but she could have chosen the second one.
I could have. All right.
Chose the third one.
Right.
I can choose any number in the sequence that I want, as long as I'm not at that first number, because I need that first
Okay,
number.
so
Wait.
since you do number 2,
We're not solving it. We're just
No,
setting
we're
up the
just-
equation.
Finding the equation.
I'm still confused.
Yeah, I
So okay, so since you're doing number 2, since you gotta multiply the previous 2 terms, I mean you have to do the third one, right?
Yes, because I'm going back 2 spaces.
Did you understand that? Okay, so it says she has to multiply the previous 2 terms, which means she needs to have 2 terms only.
So this says I need the previous 2 terms. So that means I need 2 numbers before the number I'm trying to find. I need this number and this number.
Would it be a n minus 2 times a n minus 1?
Uh-huh. There's not enough paper in there. My fat butt just squashed it. Okay, so if I'm trying to find this number, it says I need to go back 2 spaces and 1 space. I need the previous 2 terms. So a sub n minus 2, it's 2 spaces back. And a sub n minus 1, it's 1 space back. And what do I need to do to them? I need to multiply them. Oops. A sub n minus 2 times a sub n minus 1. Technically, this should be b because it's talking about b. But I
So
don't
it
know.
would be B.
B sub n minus 2 and b sub n minus 1.
So wait.
It doesn't really matter what letter.
So A just really doesn't matter.
No.
And
A is just what they're calling the sequence. I could call the sequence K for Kimberly.
So let's say there's 3 sequences. Then it would matter. Like, would you like
Well, yeah, if you're using each sequence separately, yes.
and it's where it's at.
Okay, let's look at 3. So 3 says I need the previous term. So I need 1 space back, and this is u. So u sub n minus 1. I need the previous term. What am I doing to that previous term?
Adding that
Plus 9
over 4.
all over 4. Okay? I need the previous term for this one. A sub n minus 1. Now, what am I doing to that previous term?
Something
less than double the previous term.
So how do I write 5 less?
Minus 5.
Minus 5 and put a 2 in front of A because I'm doubling the previous term. So that means I'm multiplying it by 2.
You lost me on this one.
Okay, talk to me.
I would assume the next value would be n. You explain. Like A is.
Could
Okay.
you not have at the input times 2? Or no?
It's 5 less than double the previous term, so you want to double that term first before you subtract 5.
Yeah.
You have got to watch the words. 5 less than double the previous term. Remember, you should always multiply before you subtract.
It's gonna be the unit.
Yeah, probably like an
This is going to be the unit you fail.
80 on this.
No, bitch, I'll probably get 60.
We're going to practice some more. I got you.
Please. It's not about the word.
All right. Last little bit that we've got to do with this section is, can you find the terms of the sequence? If I give you an equation, can you find me the next 3 terms in the sequence? So, hold on. Chillax. Okay, so here's my sequence.
Wait, how did you,
What is that telling me?
why did you cut it off right there? I thought it would be plus the other.
It just doesn't like.
Like, why did you cut
Did
it
you
off
not
right
see the
there?
semicolon?
Oh, no, I did not.
Yeah, there's a
I was
semicolon there.
just looking at that.
Okay. There's a semicolon there. What is this telling me to do?
The
What does A sub n minus 1 mean?
previous term.
Previous term
Minus 3.
minus 3. So right now they're telling me that A sub 1, this number right here, A sub 1 is 25.
So you subtract 3.
So to find the next term, I need to use this number and subtract 3. So what does that make A sub 2?
22.
Wait. No.
And then 19.
Okay, they want one more number.
Oh, 16.
So 60.
Sorry for the interruption. I need to make an announcement. If we have any students who attend DCCC classes, those classes, day classes, have been canceled for today due to the power outage. Thank you.
DCCC lost power.
Oh, wait, I have a question. Wait, so
Yes.
that means- Okay, so it says previous one
Mm-hmm.
is subtracted by 2.
Mm-hmm.
Then what?
So what your equation's telling you is to get this number, I need to go backwards to here and subtract 3. To get this number, I need to go backwards to here and subtract 3. To get this number, I need to go backwards to here and subtract 3.
Oh, okay.
So that's my pattern throughout the whole sequence. So I can keep going. We'll go to 13,
Really? It
then to
won't-
10, then to 7, then to 4.
I don't know why I keep thinking that you add 3%.
Because you probably think because it said previous. Since you're going back, you have to go forward.
The whole point of recursive is you need to know what happened before I can move forward.
But it's not telling you to get the first number. It already gave you the first number.
It gave you the first number.
So you have to
That's
get
what
the
this is.
second number. If you get the second number, you have to go back to the first number and subtract. Not like that.
See, but I'm thinking so. It says
If you were going back from the 25, you would have to add 3 to get that number. Because you have 22 plus 3 is 25.
See, that's what I'm trying to
So she's trying to work backwards and find like A sub 0 and A sub.
Okay, so she's
No.
thinking that since he gave you 25,
Mhm.
since you had to go back and add 3, she's thinking that you had to subtract 3. She's thinking you had to add 3 to get the numbers after 25, since it said subtract 3.
They're trying to find the previous one.
Right.
Subtract 3, you gotta.
You're
add 3.
not finding the previous one. You're using the previous one to find the next one.
Oh.
Yes. You're trying to find, so in other words, you're trying to find A sub 2 by using A sub 1 and subtracting 3. So in order to get this one, I need to go backwards to the one that came before it and then subtract 3. Does that make more sense now? Anybody else? I told you it's going to get hard right before your final. We are about to hit the hardest chapters in Discrete.
Which one? This one or the next one?
All of it. Because we're about to jump into probability, and y'all, as soon as I hit probability, everybody like,
Everyone.
and I'm not kidding, it's all over that final.
I don't know about everyone.
Maybe not everyone, smarty pants. Okay, so let me see if this will help. So right now, I know that my sequence starts with 3. I need to know the next 3 numbers. So according to my equation, what do I need to do to 3 to get my next number? Multiply by 4. So if I multiply by 4, that gives me 12. Multiply by 4, 48. Multiply by 4. What'd you say? 192. Did that help, Kimberly? Nope. Nope. Okay, my next sequence, it starts at 5. I need to come up with the next 3 numbers. According to my equation, what do I need to do to 5 to get my next number?
Multiply by 4.
Multiply by 4 and then add 1. 21. Oh my goodness. If this thing does not stop popping up here. Okay. Then I need to take that. Again, multiply by 4. Add 1. 85. I then need to multiply by 4 and add 1. You said 141? 341. 85, 341.
Okay, so basically, it's just the AN minus 1 that confuses me because I would.
That's what catches everybody. Yeah. All that means is, so you've got 4 times u sub n minus 1. All that means is I'm taking this number and plugging it in for here like it was x. So 4 times 3 gives me 12. Then I need, instead of 3 there, I need to plug in 12, which gives me 48. And then instead of 12 there, I need to plug in 48.
I get that the A doesn't matter and then the N is the number. Why does it say minus 1? I know it's to get the previous one, but why is it always there?
Because to get this number, I need to go back 1. To get this number, I need to go back 1. It's telling you what number to use, what number gets plugged in to here.
I get that.
So in other words, if this is u sub n, I need to go backwards 1 space and multiply by 4 to get that number.
Yeah, well,
I'm so lost.
I know you gotta go back one.
That's really all you need to know about it. Is that tells you to go one space back. So in other words, hold on, let me see if I can do this. I'm just making something off the top of my head here, so bear with me. 3, 6, 9, 18, 27. Okay, so let me try this. All right, so in order to get this number, I go back here and I multiply that by 3.
So it would be AN minus 2.
So because it's this number, it's A sub n minus 2 times 3. So in other words, to get this number, what number would I plug in for A sub n minus 2? 18, the number that's 2 spaces back.
Okay, kind of makes sense. How about you, Ashley? That kind of clears up.
I don't know how else to.
Okay, yeah, I'm kind of good.
How many others are absolutely still 100% like completely what in the world is this? Be honest.
Yeah.
Why is your phone even out? You know better.
It ain't out
Mm-hmm.
all the time.
Mm-hmm. Okay, let me try another one. Hi. Seriously, there's nobody on the freshman hallway that you could have borrowed one time?
We in this art room.
All right, let's see. Okay, what's my pattern? Plus 2. Each time I'm adding 2. So if I need to find this number, I need to use what number? 8. I need to use the number that comes before it. So if I'm trying to find A sub n, I need to go one space back. So minus 1. And what am I doing to that number? Adding 2. It's just telling you, you don't want to use a number there. Because if you use a number there, that means you've got to use that number over and over and over again. So I can't write my rule as 8 plus 2. Because then I can't reuse it. That means I'm taking 8 and adding 2 every time. I need this number to continue to change. But I need to tell it what number to use. So in other words, so I would plug in 8 here and then add 2, which gives me 10. To go to my next one, again, I need to go back only one space. So instead of this being 8 again, this is now 10 plus 2. Are you still?
Okay, it made sense And then when I try to do number 4 by myself, like I got it, but I'm pretty sure.
Okay. Let's try number. Hold on. What time do we have again? 12 o'clock. We got like 10 minutes. Holy cow. No. All right. So my equation here. So we start my thing off with 6, and I need to find the 3 numbers that come after 6.
I got that.
Okay. So everybody good here?
Yeah.
Okay. So my equation is 3 times b n minus 1 minus 11. Okay. So this means to find this number, if this is b sub n, I need to go backwards and 6 needs to go here.
See, I got that.
3 times 6 is
15.
minus 11.
7.
So that means this number is 7. Now I need to get this number. So again, I have to go backwards to this number. Instead of using 6 again, I now need to use the number that I got previously. 3 times 7 minus 11. We're now at 10. And to get this one now, I need to go 1 back. So 3 times 10 now, minus 11. 19. So when they give you that starter number, every time you get a new number, that's what replaces what you have. So this one, my equation starts -1. I need the next 3 terms by using 7 minus 2 times r sub n minus 1.
Hold on.
So
So it's 5r n minus 1.
okay, let's start first. Put parentheses around the rn minus 1, and then that's where 1 would go.
That's where your numbers plug in. Okay, that is where your numbers plug in. And because it's -1, that means if I'm trying to find this one, I need to go 1 space backwards and use that number. So 7 minus 2 times -1.
I got
Mm-mm.
positive 9.
+9. -2 times -1 makes that a +2, and 7 plus 2 gives me 9. So now to find the next one, again, I need to go back 1. 7 minus 2 times 9. It should be -11.
What did you? Whoa. It should be-
Wait, how should it be -11?
Yeah,
If you have 7 minus 2
it's 5.
times 9.
First off, order of operations,
Oh.
2 times 9 is 18, and 7 minus 18 is -11.
Oh, I just went straight.
She's a
Order
teacher,
of
she
operations,
knows.
come on! That stuff doesn't leave you.
That stuff doesn't work.
It does. And if you would actually just plug literally this into your calculator, it does order of operations for you, so you don't even have to think about it.
I did my.
So now 7 minus 2 times -11. So -11 times -2 is
Positive
22.
22. And then put the 7 in, we're at 29.
I kind of feel better.
You kind of feel better? We're gonna see when you actually try your homework tonight.
Oh, no.
Ah!
No, ma'am.
Yes, ma'am. Yeah, you forgot I'm that mean teacher that always gets homework. I enjoy it though, it's fun.
Not like
Yeah.
All right, there are two very special kind of sequences that we are going to talk about. These are the only two that you are going to need to know for your test. One is called an arithmetic sequence. Yes, arithmetic. Arithmetic, I don't know why they get fancy when they call it arithmetic instead of arithmetic. But what does arithmetic mean? Add, subtract. So guess what? An arithmetic sequence is a pattern of addition or subtraction by a constant value. So in other words, if I start by adding 2, I add 2 every time. If I start by subtracting 7, I subtract 7 every time. The value that you add or subtract is what we call the common difference, which is represented by D. Okay? Your recursive rule for these will always be the previous term plus or minus whatever your difference is. Slowly running out of time. Okay, so in other words, the first thing you need to do is find your pattern. Okay, so what is my pattern in example 1 here on the left? What is happening each time I move forward?
Adding.
Okay, we're adding, it's getting bigger. What am I adding?
Oh, wait. So I was right, it's adding. So
Yes, it's getting bigger, so you're adding. You're adding 17. Okay, a good way and an easy way to find this. Pick any number you want. So, 59. Subtract the number before it. And that always, always gives you your common difference. Every time. If it comes out positive, that means you were adding along the way. If it comes out negative, that means you were subtracting along the way. So, my recursive rule here then is a sub n minus 1 plus 17. Every time I'm using the number that I have and I'm adding 17.
So we'll have to write like that, like that.
This one's going to be plus because it's getting bigger each time. But if it was getting smaller, if we were subtracting, it would be minus. Okay. So, example number 2. Right away, we know that this is subtraction because it's getting smaller as I go. And again, I can find that by picking any number I want, 11 minus 1, and I subtract the number before it, and that gives me my pattern. So each time I'm subtracting 2.6. So my rule is a sub n minus 1 minus 2.6. Finally, example 3. Should this be plus or minus? This should be plus. It's getting bigger.
3.38.
You said 3.38?
Yeah.
Again, 9.05 minus 5.67. You said
3.38.
I kept wanting to put 8 before the 3. So my rule here is I'm adding 3.38. So a sub n minus 1 plus 3.38. So arithmetic, I'm always adding or subtracting the same number. If my pattern's like plus 2, then plus 3, then plus 2, then plus 3, it is not arithmetic. Yes, ma'am. Okay. So arithmetic is adding or subtracting. Geometric is multiplication. Okay, you're multiplying by the same number over and over again, whether it be a fraction or a whole number. Okay, it's always multiplying. And they now call this your common ratio instead of your common difference. Well, my recursive rule for that is R times A sub n minus 1. Whatever I'm multiplying by times the number that I know. Some of these are going to be really easy to notice. Other ones you're actually going to have to solve for.
So, geometric is just multiplication.
Yes. It would technically be division too, but division and multiplying by a fraction does the same thing. So I can either divide a number by 2 or multiply it by 1/2, and it's the same thing. So they want you to stick with multiplication. Okay. So example 1, what am I multiplying by? 5. Okay. Just like addition and subtraction, I can find that if I can't see it. So if I take 15 and I divide by the number that comes before it, that gives me my R value. So if you're not good at finding that pattern, you can find it. Okay, so this would be 5 times A sub n minus 1. This next one, this is not easy to find. So use this. You can use any number you want. So I'm going to go to 98. What's 98 divided by 56?
1.75.
1.75. So that means every time I multiplied by 1.75. So 1.75 times A sub n minus 1. Okay. This last one.
Yeah,
Okay.
you would link that example to you.
9 divided by 18, the number that comes before it. Either 1/2 or you can use 0.5. I don't care. Okay, so 0.5 times A sub n minus 1. What were you saying about example 2?
You would think that since it's like the opposite, that it would be somewhat addition, you know? Like, you gotta subtract for the first one.
It would have been plus 24 if it was added.
And plus 24 doesn't work from 56 to 98. That's how you know it's not addition. Okay, so that actually is wonderful. So Ashley said if I were adding on this one to go from here to here, I would have added 24. Well, how do I know that this is not addition? What happens when I add 24 to 56? It doesn't give you 98. This only gives me 80, which tells you that it's not addition. Okay, so that's a good way to check yourself. It tells you that it's not arithmetic. Okay, questions?
No.
Okay, I know the next page says warm up, and the back side of that says homework. Okay, I want you to try both.
Oh.
Okay. The longer we spend practicing this, the easier it will get.
Oh, so
Okay.
this page is homework?
So both
Yes,
of
that
them?
page